manual starter, even when equipped with a lockout device and the stop button, is generally not considered a motor disconnect located within sight of the motor, according to electrical codes and standards. Several factors contribute to this determination. The primary function of a motor disconnect is to completely isolate the motor from its power source, ensuring safety during maintenance, repairs, or any situation where the motor needs to be de-energized. A manual starter, on the other hand, is designed to start and stop the motor under normal operating conditions and provide overload protection. Firstly, the definition of disconnect in electrical codes, such as the National Electrical Code, or NEC, emphasizes the ability to completely cut off the electrical supply. This typically requires a device that provides a visible break or a clear indication of the open circuit. A manual starter, even with a lockout, doesn't always provide this visible break. The internal contacts of the starter might be open, but there is no readily apparent way to verify this without further inspection or testing. Secondly, the within sight requirement is intended to ensure that the disconnect is easily accessible and controllable by the person working on the motor. The NEC typically defines within sight as being visible and not more than 50 feet or 15 meters away from the motor. This proximity allows the person performing the work to quickly de-energize the motor if an unexpected hazard arises. A manual starter, while it might be located near the motor, might not meet the specific requirements for a disconnect switch in terms of visibility and accessibility. Thirdly, the underwriter's laboratories, or all listing and labeling of electrical equipment play a crucial role. A device intended to serve as a motor disconnect must be specifically listed and labeled for that purpose. Manual starters are generally listed for motor control and overload protection, not for disconnection. This distinction is important because the construction and testing requirements for a disconnect switch are more stringent than those for a starter. Fourthly, the NEC section 430.102 addresses motor disconnecting means. It requires that a disconnecting means be provided for each motor and that it be readily accessible. The disconnecting means must be capable of being locked in the open position, or it must be located so that it is permanently within sight of the motor controller. This section reinforces the need for a dedicated disconnect switch, separate from the motor starter, to ensure safety. Fifthly, consider the operational characteristics of a manual starter. It's designed to handle the inrush current associated with starting a motor. However, it's not necessarily designed to interrupt fault currents or provide the same level of isolation as a disconnect switch. A disconnect switch is typically rated for higher interrupting capacity and is designed to withstand the stresses of a short circuit. Sixthly, the lockout/tagout, or LOTO, procedures emphasize the importance of isolating energy sources during maintenance. A manual starter with a lockout and the stop button can prevent the motor from being restarted accidentally, but it doesn't guarantee complete isolation from the power source. A disconnect switch, when locked in the open position, provides a positive means of isolating the motor from the electrical supply. Seventhly, the requirements for motor disconnects can vary depending on the voltage and horsepower rating of the motor. For larger motors, the NEC typically requires a horsepower-rated disconnect switch. This switch must be capable of interrupting the motor's full load current and locked in the open position. A manual starter might not meet these requirements, especially for larger motors. Eighthly, the electrical inspector has the final say in determining whether a particular installation complies with the NEC and other applicable codes. The inspector will consider all of the factors mentioned above, as well as any local amendments to the code. It's always a good idea to consult with the local electrical inspector before installing a motor and its associated control equipment. Ninthly, consider the safety implications of using a manual starter as a motor disconnect. If the starter fails to open the circuit completely, there could be a dangerous voltage present at the motor terminals, even with the lockout engaged. This could create a shock hazard for anyone working on the motor. A disconnect switch, on the other hand, provides a more reliable means of isolating the motor from the power source. Tenthly, the maintenance and testing requirements for disconnect switches are different from those for manual starters. Disconnect switches should be inspected regularly to ensure that they are operating properly and that the contacts are clean and free of corrosion. Manual starters should also be inspected, but the focus is typically on the overload protection and the condition of the contact. In summary, while a manual starter with a lockout device can provide some degree of safety, it's not a substitute for a properly sized and installed motor disconnect switch. The disconnect switch must be readily accessible, capable of being locked in the open position, and listed for use as a disconnecting means. It must also meet the requirements of the NEC and other applicable codes. To further elaborate on the differences and requirements, let's consider several additional aspects. We'll begin with a deeper dive into the within-sight requirement, continue into the practical applications, and then detail the specific types of disconnects that are acceptable. The within-sight rule has a specific intent. It's not merely about being able to see the disconnect. The purpose is to allow the person working on the motor to control the power to the motor while directly observing it. This minimizes the risk of someone inadvertently re-energizing the motor while work is in progress. Imagine a scenario where an electrician is repairing a motor and someone else, unaware of the work being done, starts the motor from a remote location. The within-sight rule aims to prevent such situations. The NEC clarifies within sight to mean visible and not more than 50 feet or 15 meters away. This distance is crucial. It's intended to be close enough that the worker can quickly reach the disconnect in an emergency, but far enough to provide a safe working distance from the motor itself. The disconnect must be easily accessible, not obstructed by equipment or structures, and clearly labeled. Now let's discuss practical applications. Suppose a small motor is located inside a piece of machinery. The manual starter is mounted in the machine's control panel, which is also located on the machine, and is within sight of the motor. Even though the starter is close and visible, it still doesn't qualify as the required disconnect. A separate disconnect switch, mounted on a machine and clearly labeled, would be necessary to comply with the code. Consider another scenario. A large motor is installed in a pump house. The manual starter is located inside the pump house, near the motor. However, the pump house is locked, and the electrician must walk around the building and use a key to access the starter. In this case, the starter might be within sight of the motor, but it's not readily accessible. A separate disconnect switch, mounted outside the pump house and easily accessible, would be required. Now let's discuss the types of disconnects that are acceptable. The NEC recognizes several types of disconnect switches, including safety switches, molded case circuit breakers, and motor circuit protectors. Safety switches are typically enclosed in a metal cabinet and have a handle that can be locked in the open position. They are available in a variety of sizes and voltage ratings and are commonly used as motor disconnects. Molded case circuit breakers can also be used as motor disconnects, provided that they are marked suitable for use as a motor disconnect. These breakers have an interrupting capacity and can provide overload and short circuit protection. They are often used in motor control centers and other industrial applications. Motor circuit protectors, or MCPs, are specifically designed for use in motor circuits. They provide short circuit protection and can be used as a disconnecting means when marked suitable for use as a motor disconnect. MCP are often used in conjunction with motor starters to provide complete motor protection. The choice of disconnect switch will depend on the specific application and the requirements of the NEC. Factors to consider include the voltage and horsepower rating of the motor, the available fault current, and the environmental conditions. It's always a good idea to consult with a qualified electrician or engineer to select the appropriate disconnect switch for a particular installation. In addition to the NEC, other standards and regulations might apply to motor disconnects. For example, the Occupational Safety and Health Administration, or OSHA, has specific requirements for lockout/tagout procedures. These procedures require that energy sources be isolated and locked out during maintenance to prevent accidental startup. A properly installed and maintained motor disconnect switch is essential for complying with OSHA's lockout/tagout regulations. Furthermore, some local jurisdictions might have additional requirements for motor disconnects. It's important to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. To ensure the safety and reliability of a motor installation, it's crucial to understand the requirements for motor disconnects. A manual starter with a lockout and the stop button might provide some degree of protection, but it's not a substitute for a properly sized and installed disconnect switch. The disconnect switch must be readily accessible, capable of being locked in the open position, and listed for use as a disconnecting means. It must also meet the requirements of the NEC and other applicable codes and standards. Remember, safety should always be the top priority when working with electrical equipment. Ignoring these requirements can lead to dangerous situations and potential injuries. Always consult with a qualified electrician or engineer to ensure that the motor installation is safe and code compliant. Consider also the arc flash hazard associated with electrical equipment. An arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. The arc flash can generate intense heat, pressure, and light, and can cause serious burns, injuries, and even death. Motor disconnect switches play a crucial role in reducing the risk of arc flash. By providing a means of isolating the motor from the power source, disconnect switches can help to prevent arc flashes from occurring during maintenance or repairs. The selection and installation of motor disconnect switches should be performed by qualified personnel who are trained in arc flash safety. These personnel should wear appropriate personal protective equipment, or PPE, and follow safe work practices to minimize the risk of arc flash. Arc flash studies can be performed to determine the potential arc flash hazard at a particular location. The results of the arc flash study can be used to select the appropriate PPE and to develop safe work procedures. In addition to the arc flash hazard, there is also the risk of electric shock. Electric shock can occur when a person comes into contact with energized electrical equipment. The severity of the shock will depend on the voltage, the current, and the duration of the contact. Electric shock can cause burns, muscle contractions, and even death. Motor disconnect switches can help to reduce the risk of electric shock by providing a means of isolating the motor from the power source. The installation of a proper grounding system is also crucial for electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system should be inspected regularly to ensure that it is in good condition. In conclusion, a manual starter with a lockout device and the stop button is not typically considered an adequate motor disconnect within sight of the motor. The requirements for motor disconnects are designed to ensure the safety of personnel working on electrical equipment. These requirements are outlined in the NEC and other applicable codes and standards. By following these requirements, we can help to prevent electrical accidents and injuries. Always prioritize safety when working with electrical equipment, and consult with qualified professionals to ensure that the installation is safe and code compliant.